Shri Dhanvantaraye Namaha. Shubha Madhyana to everybody present here. Gnananandamayam Devam Nirmalasphatiकाकृतिम् Adharam Sarva Vidyanam Hayagrivam Upasmahe. Om Namami Dhanvantarim Adidevam Surasurair Vandita Padapadmam Loke Jararubhaya Mrityunasham Dataramisham Vividaushadhinam. Good afternoon, everybody. I am myself Dr. Ranjini Deshpande, MS Shalyatantra from Government Ayurveda Medical College, Bengaluru. First of all, my sincere thanks to the team of Tadvidya Sambhasha for having initiated such a wonderful platform for students to access to the knowledge of Ayurveda. And I'm again thankful for making me a part of this wonderful forum. As being discussed earlier with the members of Tadvidya Sambhasha, from today I will be starting with Shalyatantra paper 2 of the UG syllabus, and as of now today we will be starting with the Bhagna topic. So as a part of syllabus, the topic of Bhagna, it involves the skeletal injuries, the prakara including pathological fractures, the samanya lakshanas, upadrava and chikitsa. We also have the next point that deals with the description of fractures of certain basic bones like scapula, humerus, radius, ulna, femur, patella, etc. And also the various, again, the classification, pathological features, complications, upadrava, treatment, everything of the sandhi moksha, that is dislocation. So today we will be mainly focusing on the basics before we deal into the depth of the chapter of fractures, and that will be anatomy and physiology of the bones. So this is the very basic topic. One thing I want to highlight here is that all the session will be not just focused with respect to the UG syllabus, but it's also with respect to the PG syllabus as well. As we know that PG examinations are coming forward, so these sessions will also help the PG students appearing for their final year examinations. So today we will be dealing with the basics, that is the anatomy and physiology of the bone. Anatomy and physiology of the bone. Now this particular topic, there's a very small topic which is also included in the PG syllabus as well under the context of Bhagna. So this I want to highlight. Now we will start with the basic, today's lecture. So first of all, we have the human skeleton. So the human skeleton can be broadly classified into two, that is the axial skeleton and the appendicular skeleton. Now this is a basic classification. As we all know, axial skeleton includes the skeletal system of the head region, the neck region and the trunk region. That is And as we know, the appendicular skeleton, it deals with the skeletal system of the upper and lower limbs. So this is the first classification we have to know. So under this we will be, what are the bones that come under this? Under the head we have the cranium, with the neck we have the vertebra, the trunk we have the bones of the trunk. Here we have the skeletal apparatus or the bony structures of the upper limb and the lower limb. We have the pectoral girdle and we have the pelvic girdle, all of which comes under this particular classification. So here we learned that human skeleton has basically two classifications. One is the axial skeleton and the other is the appendicular skeleton. Now we know the basic classification. There is another classification. This was with respect to the anatomy, the basic anatomy where the skeletal system lies. Now the next classification is on the shape and structure of the bones. So usually it is only 4 classification, but a 5 classification also doesn't harm, and the 5 classifications can be understood with a small mnemonic, that is S, S, I, L and F. Now what does all of these stands for? So S stands for short bones, another S for sesamoid bones. The next I stands for irregular bones, L for long bones and F for flat bones. So this is the basic classification again, based on the size and based on the structure or the morphology of the bone. So we have short bones, sesamoid bones, irregular bones, long bones and flat bones. Now all of us know many examples under these. Just to quote one examples under all of them. So short bones, we can the example is the bones, that is the carpal and tarsal bones. That is for short bones. For sesamoid bone, the very famous patella. Next, for irregular bones, we have the vertebral bodies. For long bones, famous in its classification, we have the femur. Flat bones, we can go with manubrium. So this is the next classification. SSILF is the mnemonic SILF. We have the short, sesamoid, irregular, long, flat bones. To quote an example under each of them, we have for the flat bones manubrium, for the long bone femur, for the irregular bone we have the vertebral bodies, for the sesamoid bone we have the patella, for the short bones we have the carpal and the tarsal bones. So until now we have got to know the basic classification of bones and the skeletal system. Excuse me. Now we will move to the macroscopic and microscopic structure of the bone. So first we will deal with macroscopic structure of the bone. Now for suppose we take the typical example of a long bone, that is the femur. Okay. So suppose it's a crude figure of femur. So here, what are those, the macroscopically, what are the features that we can appreciate? So the center is usually the spongy bone at the ends. So this is called as spongy bone, or it's also called as trabecular bone, or since it is inside, it is also called as inner bone. Okay, now the next is, we have the center part, the cavity. This is called as the medulla. This is where the bone marrow is present. And next is the outer part. So this is also called as dense bone, compact bone, or it's also called as the outer bone. So this is the basic macroscopic structure of the bone. So we have the inner part, which is the spongy bone or the trabecular bone, or it's also called as the inner bone. Next, we have the medulla part, which is the inside cavity, which has the bone marrow in it. Next, we have the outer, that is the compact bone, the dense bone, or it is also called as outer bone. Now, in this structure, we have certain differentiations to make. So, what can those be? So, we have the two ends, we have the mid shaft, and we have the space between the two ends and the shaft. So we have certain names that are given to these structures or spaces, which I will indicate on this side. So this at the two ends of the bone is the epiphysis, that is the epiphysis. Next we have the center. This part is called as diaphysis, and that region that separates the epiphysis from the diaphysis, this is called as the metaphysis. So to put in a single sentence, what we could say is metaphysis is that which separates the two ends of the epiphysis from the diaphysis of the bone. Metaphysis is that separates the two ends of the epiphysis, that's the two ends of the bone, which is the epiphysis, from its diaphysis. So to remember, center part, epi is something at the ends, so it is at the two ends, so we know that can be kept in mind, it's epiphysis. Diameter is something that is taken, that is measured at the center of any structure. So diaphysis signifies the center part of the bone, so this is the diaphysis. Which separates both of them is called as metaphysis. Now we have another thing also to remember here, which is that epiphyseal plate. Now the epiphyseal plate is something that lies between the epiphysis and metaphysis. It lies here. At the two ends, we have the epiphyseal plate. So what is this epiphyseal plate? This epiphyseal plate is a cartilaginous plate. So this epiphyseal plate is a cartilaginous plate which forms a major role in the bone growth or lengthening after birth. So the lengthening of any bone, it happens at the epiphyseal plate. So there are various theories on that also, but as of now, epiphyseal plate is that which has a major role in the growth or the lengthening of the bone. Next, coming to the articular surfaces now. So now we saw the epiphysis here. We have the epiphyseal plate. We have the metaphysis. We have the diaphysis. And again the same continues in the lower portion. Now here we have something else. So what is that? So here, the articular surface of the epiphysis is covered with articular cartilage. Again, the articular surface of epiphysis. So whichever is the portion of the bone that is itself indulging in the articulation, that surface is covered by articular cartilage. Now, what is the rest of the surface of bone covered with? It is covered with periosteum. It is covered with periosteum. Here, the articular surface at the epiphysis is covered by articular cartilage. And the rest of the bone is covered with periosteum. So this is what we have to see. Again here, the periosteum is a double layered structure. It is not single layer. The periosteum is a double layered structure. It is made up of one layer is cellular and the other layer is fibrous. Now we have certain fibrous strands that runs from the periosteum to the bone surface. So from the periosteum to the bone surface, we have certain fibrous strands running through, and this is called as, I shall write it here, and this is called as Sharp's fibers. So it is these fibers that run between the periosteum to the bone surface. So in the macroscopic structure, what we see, we'll just brush across. We saw a lot many things. So at first, a typical long bone. At the center, we have the spongy bone. It's also called as the trabecular bone, or it is also called as the inner bone. Next, in the center, we have the medulla, where we have the bone marrow. Next, at the outer part, we have the bone or the outer bone. Next, we came across certain names that are given to across the length of the bone. The two ends are called as epiphysis. The center, the diaphysis, the center part is called as the diaphysis. And that part between the epiphysis and the diaphysis is called as the metaphysis. Now, there is also a thin cartilaginous plate between epiphysis and metaphysis. This is called as the epiphyseal plate that has a major role in lengthening of the bone. Next thing what we saw was the covering. At both the ends of epiphysis, whichever is the part of the bone that is indulging in articulation, that part is covered with articular cartilage, and the rest of the bone is covered with periosteum. Coming to the periosteum, periosteum is a double layered structure. It has two layers. One is cellular layer and the other is fibrous layer. There are certain fibrous strands that run from the periosteal layer. These strands are called as Sharp's fibers. So this is the macroscopic structure of bone. Now further, we will be dealing with the microscopic basic structure of the bone. The microscopic structure of the bone. Okay, now we move to the microscopic structure of the bone. Now, microscopically, the bone can be classified as either, so this is with respect to the bone. So the bone can be classified either as woven bone or lamellar bone. I repeat, microscopically, the bone can be classified as woven bone and lamellar bone. Now we have the woven bone. What is the basic difference between both of them? In the woven bone, two basic difference is with respect to the bone cells, and the next is collagen. Kindly excuse. I hope the audio and video of the session is clear. If any one of you could kindly put an update on the message box, it would be very helpful for me to continue the session. Okay, I hope it is clear. So I'll be continuing with the session. So the difference is with respect to the bone cells and the collagen. Now what happens in the woven bone? we have the bone cells and the collagen. Bone cells are scatteredly arranged. The bone cells are scatteredly arranged and the collagen also is disoriented. The orientation of the collagen fibers is not in the same pattern. The disorientation pattern of collagen fibers is seen in the woven bone. So we have the bone cells scatteredly arranged or it is loosely arranged. The arrangement is not in any symmetry, and even the collagen, there is disorientation pattern of the collagen fibers in the woven bone. Next comes the lamellar bone. So definitely it is the opposite of it. In the lamellar bone, the arrangement is, there is neat arrangement or a coordinated arrangement of the bone cells, and the pattern, the collagen pattern is oriented. Collagen pattern is oriented. So this is the microscopic structure of the bone. The basic is we have the woven bone and we have the lamellar bone. The woven bone, the bone cells and the collagen are scattered and they are disorientedly arranged. Pattern is disoriented. In the lamellar bone, the bone cells are neatly arranged in a pattern and we have a coordinated pattern of arrangement of the collagen. Now, where will these woven bones play a role? So, especially during fracture healing, in the initial phases, we see rapid bone healing process or bone development process where new bone cells are laid upon. So, in that stage, we have this woven bone to get associated with the process. Now, where is the lamellar bone? See, usually any compact bone comes under the lamellar bone. Now, the lamellar bone again is of two types. Wherever there is lamellar bone, it is of two types again. That is cortical and cancellous. So, the lamellar bone, we have the cortical bone and the cancellous bone. Now, what is the difference between cortical and the cancellous bone? Again, this can be known with respect to a long bone, with an example of a long bone. Now suppose this is the long bone. So the cortical bone is that where the lamella is dense. So we have the cortical part. This is where the lamella is dense. The cortical part, we have the lamella which is dense. Now we have the cancellous part which is at the ends. So this is the cancellous part where the lamella is loose. It is not dense, it is loosely arranged. It is not compact in simple words. That is, there is a loose lamella. So we have the lamellar bone. The lamellar bone is of two types, the cortical bone and the cancellous bone. In the cortical bone, the lamella is dense and that is why it is called cortex, and it is usually seen in the shaft, near the shafts. So this is cortical bone, and the cancellous part is usually seen at the end where the lamella is loose and not dense. So that is called as the cancellous part. We have one important thing which is the cortico-cancellous junction. So this is the junction. This is cortico-cancellous junction. Now what is the importance of this, clinical importance of this cortico-cancellous junction is that it is at this site where fracture tends to happen more. So the tendency for a fracture to happen for a very minimal amount of stress is more at the place of this cortico-cancellous junction where fracture occurs very easily. So until now we have seen the two things, that is the macroscopic structure of the bone, and now we saw the microscopic structure of the bone. Now again here there is one thing what we have to look for, that is the osteons. That is the osteons. Now what are osteons? Osteons are structural unit of the lamellar bone. So wherever there is a lamellar bone, the structural unit of any lamellar bone is called as osteons. Now typically how this osteons appear is that, so it appears as laminas. Laminate placement is there, and that arrangement is against is around the central canal. And the canal's name is called as Haverson's canal. And the canal is called as Haverson's canal. Now this will move longitudinally, and this will meet another canal which runs horizontally between the endosteal surface to the periosteal surface. So this is the inner part of the bone. If you can imagine, this is the outer. So there is a canal that runs horizontally. This is called as Volkmann's canal. This is called as Volkmann's canal. So this is the basic structure of the osteon. And what is important is that it is through this that we have various blood vessels that moves and supplies nutrients to the bone. So this is the basic microscopic structure of bone that we saw. To just brush up, so in the microscopic view we have the two types, the woven bone and the lamellar bone. In the woven bone is that wherein the bone cells and the collagen are not placed or are not in a systematic structure or pattern, whereas in that of the lamellar bone, the bone cells and the collagen are oriented in a very good pattern. The lamella is again of two types, the cortical bone and the cancellous bone. The cortical bone is that which is usually found near the dense part, that is the compact bone, which is found at the shaft of the bone, and the cancellous part is seen at the ends of the bone. We have something that is called as cortico-cancellous junction. That's the junction between the cortical part and the cancellous part of the lamellar bone. This place is of clinical importance because fracture tends to happen more at this cortico-cancellous junction. We next saw what osteons are. Osteons are the structural unit of the lamellar bone. So it is arranged in the laminal form around a canal that is called as Haverson's canal. This runs longitudinally and it meets then wherever in many places within horizontal canal, that is the Volkmann's canal, that runs from the endosteal surface to the periosteal surface. So until now we have seen the classifications of bone, the basic classification of the skeletal system, the classification based on the structure and shape of the bone. We saw the macroscopic structure and the various names given to the various parts of the bone, and now we saw the microscopic structure of the bone. Now we will see what is the structural composition of the bone. Now we will see the structural composition of the bone. So what is bone tissue made of? Bone tissue is made of two things. One is bone cells and the other is extracellular matrix. So the structural composition of the bone is made up of bone cells and the extracellular matrix. What are these bone cells? We will see it further. Now we will see what is this extracellular matrix comprises of. This extracellular matrix is again of two types. That is, we have the organic matrix and the inorganic matrix. Okay, Now, under organic matrix, we have the collagen. Under inorganic matrix, we have various salts, like which are the basic salts it has, bone has, that is the calcium and the phosphorus salts. So these are the main two inorganic extracellular matrix which forms the composition of the bone tissue. Hydroxyapatite is one of the major. So here collagen forms around 30 to 35% of dry weight of bone. So the rest is, we have 65 to 70% of the dry weight of bone is from the inorganic matrix material. So we'll see it again. The structural composition of the bone, it is made up of bone cells. Bone cells we will be dealing again now in some time. And the rest is extracellular matrix. Now what does this extracellular matrix comprise of? It comprises of the organic matrix and the inorganic matrix. Now what do we have under the organic matrix? Under the organic matrix we have collagen, which forms 30 to 35% of dry weight of the bone. The inorganic matrix is mainly the salts, that is, we have the calcium and the phosphorus salts that comprises of 65 to 70% of the dry weight of the bone. Now we have something that we have to deal with detail, that is about bone cells. We have all known that bone cells, at least two basic bone cells are known by everybody. That is the osteoblast and the osteoclast. Now in the classification we can see two more which has its own typical functions. So that counts to four types of bone cells. So we have bone cells, 4. So now we will see what are the 4 types. The first one, osteoblasts. So osteoblasts are simple cells. They are cells of the bone which help in building up of the bone. So these are osteoblasts. So they make the bones stronger. So this is osteoblast which help in building up of the bones and it makes the bones stronger. So this is one bone cell. The second one we have is osteoclasts. The second bone cell is osteoclast. So what does osteoclast does? It causes the destruction of bone cells. So if we can depict it. So it is that which causes the destruction of the bony surface or of the bone morphology. They are called as the osteoclast. The next is the third one is the osteocyte. Now what is osteocyte? Osteocytes are nothing but mature osteoblasts that are trapped in the bone matrix. So when the osteoblast gets trapped in the bone matrix, these matured osteoblasts are called as osteocytes. Now these osteocytes are specialized cells that have many functions. They can also function take up the function of the osteoclast and they can help in the resorption of the bones. So these osteocytes are the main cells of the compact structure of the bone, that is the bony matrix is made up of the osteocytes. Next the fourth cell is osteoprogenitome cells, that is osteoprogenitome cells is the fourth one. Now what are osteoprogenitome cells? These are precursors to osteoblast cells. So these are the stage just prior to when it becomes osteoblasts. So these are precursors. So these are precursors to osteoblastic cells. So now we saw the four types of bone cells. So first we have osteoblast. It helps in building up of the bone and it makes the bone stronger. To remember, we have blast, B, and building, B and B. So it is that which helps in development of the bone, or it increases the bone cells. So production of bone cells. So osteoblast helps in building up of the bone. Next is the osteoclast. After B comes C. After building come destruction. So that's a small mnemonic to keep in mind, because usually osteoblast and osteoclast function is confused or mismatched. So osteoclast is that which does the function of destruction of bone or the resorption of bones. The third one is osteocytes. So pictorially to represent. Okay, so osteocytes are nothing but mature osteoblast cells that get trapped into the bone matrix. So these are called as osteocytes. The fourth one is called as the osteoprogenitome cells, which are just precursors to osteoblasts. So these are the four kinds of cells. Now this will be understood again with a small picture when it is written. Now suppose this is the long bone. And we expand a small portion of this here. We can now understand this. Okay, so this is the outer part. So what we saw, the osteoblasts. So now we consider this is the layer of osteoblasts. Now what we say, certain osteoblast, when it gets matured, it gets pulled up into the bone matrix. And when that happens, they are called as osteocytes. So we have, don't get confused, this is not the lamella part what we saw in the macroscopic structure. This is still the cortical part, the entire width of the cortical part which we are seeing into. So now we have the osteocytes. So this osteoblast, these are mature osteoblasts that get absorbed into the matrix. So this is osteocyte. Osteoblast has nothing also to do with the production of the matrix again. So this is osteocyte. Now covering the osteoblast, we saw certain thing, that is a layer, a double layered structure. So here we have is the periosteum layer. So between the osteoblast, then it is covered by a thick sheet, that is the periosteum. This periosteum is a double layered structure. So one, you have the cellular layer, and the other you have the fibrous layer. Now we saw that there is something called as Sharp's fibrous strands that run from the periosteal surface to the surface of the bone. So that I am not depicting it here. So as of now, we have the periosteal layer that is covering the osteoblast. Now once that gets over, now we need to show blood supply to the bone. So from where does the blood supply come from? The blood supply comes, it pierces the periosteal layer, and we saw the structure of an osteum which has canals throughout the structure of the bone. So it is through that the blood vessels communicate, or it flows through, and that is how the nutrient supply occurs to the bone. So now this is very, very important. Another thing is, where does the pain fibers reside here? Pain fibers does not reside in the cortical part, whereas the periosteum is very, very rich in pain fibers. So that is why during the fracture, when initially the periosteum layer is broken, so the pain fibers at the site is activated, and that is how we perceive pain. So now this is the basic structure. Bone cells, we saw the osteoblast, osteocytes, osteoclasts, and the osteoprogenitum cells. To see the structure in a larger sense, so this we are considering on the cortical part of the bone and a shaft of the long bone. So this layer is the osteoblastic layer that helps in building up the bone, and it helps in the production of the matrix of the bone. These are cells which are osteocytes. As we saw before, osteocytes are nothing but osteoblasts, which are mature osteoblasts that gets pulled up or absorbed into the matrix of the bone when they are called as osteocytes. We saw that osteocytes had varied functions also. Next is the layer of osteoblast is covered with two-layered structure, which is called as the periosteum. Two layers, one is the cellular layer and the other is the fibrous layer. To see the blood vessels, blood supply to the bone, the blood supply pierces the periosteal layer and it runs through the canals, what we saw, that is the Workman's canal. And that is how the bone gets its nutrients. Now this we saw until the structure of the bone. To see, typically every long bone has a certain pattern of blood supply. For today's lecture, we shall see that, revise and wind up the section. So what is this typical blood supply to any long bone? So again, suppose this is a long bone. We have four major vessels that gives its supply to the bone. So the first is, so we'll write it here first. So the first is nutrient artery. The next is the metaphyseal artery. The third is epiphyseal artery. And the fourth is periosteal artery. I repeat, nutrient artery, metaphyseal artery. Next we have the epiphyseal artery. Next we have the periosteal artery. So now we will see how it runs through the bone. So this is a typical structure when we see any long bone in our body. So this is how the blood vessels traverses through the bone. So first we have the nutrient artery. It typically enters the bone somewhere in the middle of the shaft. So we have nutrient artery. Now once it enters the middle of the shaft, it divides into two. One up and one lower. And it runs almost until the metaphysis. We know that this is the metaphysis now. This is the diaphysis, metaphysis, and the epiphysis. So this nutrient artery, it pierces the bone somewhere in the middle, moves up and down, it branches to two, moves up and down, it reaches until the metaphysis. Now what happens near this metaphysis is that it splits up into several parallel vessels. So this is several parallel vessels, and it forms an anastomosis further with the metaphyseal vessels. So this is the first artery what we saw. We shall mark it. So this is the first artery, that's the nutrient artery. The next is the metaphyseal artery. So the metaphyseal artery, it supplies the region of the metaphysis here. So it's not upside, it's inside. So I show it like this at the region of metaphysis so that it's making an anastomosis with the nutrient artery. Now from where the metaphyseal vessels derive from? It derives from the joint vessels, the vessels that participate at the articulation level. These metaphyseal vessels are derived from those vessels that participate near the articulation of the ends of the bones. So that we have the metaphyseal artery. So this is 2. Now the third is the epiphyseal artery. Again from the surrounding, the epiphyseal artery directly enters the epiphysis. The epiphyseal artery directly enters the epiphysis and supplies to the epiphyseal ends. So this is 3. We have the epiphyseal artery. Now the fourth what we saw is the periosteal artery that lies in the layer of periosteum. It is richly supplied with blood that is derived from the neighboring vessels. So that is the, I will show it between the periosteum, multiple, it's not just one there, it's densely supplied there at the level of periosteum. So this is 4. So that is the periosteal artery. So to summarize the blood vessel part, so any typical long bone will have the blood supply in this pattern or in this fashion. So the first is, there are 4 kinds of artery: the nutrient artery, metaphyseal artery, epiphyseal artery, and the periosteal artery. The nutrient artery is one that pierces the shaft of the bone almost in the middle of the shaft. It enters the bone, it splits into 2, one branch upper, one branch to the lower side. It runs all along the shaft of the bone, and then at the level of metaphysis, it gives parallel branches. So it gives a number of parallel branches at both the ends. Now what does this parallel branches do? It anastomoses with the epiphyseal artery, at the metaphyseal artery at the level of metaphysis. So we found the nutrient artery now. Next is the metaphyseal artery. The metaphyseal artery is that which supplies the metaphyseal region of the bone. Where does this derive from? This derives from the blood vessels that participate at the articulation of the ends of the bone. So we have vessels that participate at the level of articulation. So through that we have the branches, we have many branches that supply to the metaphyseal region. That is called as the metaphyseal artery. Next is the epiphyseal artery. The epiphyseal artery, it again from the surrounding structures, branches enters directly into the region of epiphysis, and that is called as epiphyseal artery. The third vessel supply, that's the nutrient supply. The fourth is the periosteal artery. The periosteal layer is abundantly supplied with vessels, with arteries. That is called as the periosteal arteries. So this is the basic of the blood vessels, or the channels of blood vessels, vascular system of the bone. So to brush up with, another small thing we have to notice, the remodeling of the bone. So there is something called as Volt's law of bone remodeling. So the last very tiny thing to cover in today's introductory class is bone remodeling. So it is one such concepts where the bone has an ability to alter itself with respect to stress on it. So this is the stress. See, the alteration happens in its shape and structure of the bone. So because of stress, there will be a continuous alteration in the bone shape and the bone structure throughout the life, which usually goes unnoticed apart from a very evitable fracture. So otherwise, usually it is not known with respect to the continuous stress that keeps on happening in our body. So what is Wolff's law of bone remodeling is that bone hypertrophy always occurs in the plane of stress. He says bone hypertrophy occurs in the plane of stress. So this is called as Wolff's law of remodeling. I repeat, there is something called as bone remodeling is a small thing that we have to understand with respect to, which will help us when we study the fracture healing. What this bone remodeling means is that there is a continuous process of alteration in the shape and structure of the bone that usually goes unnoticed by us because of continuous stress. And there is one such law that is called as Wolff's law, and he says that bone hypertrophy occurs in the line of stress. So this law feels like it's unimportant at the correct time. As and when we move with a detailed explanation of the fracture of individual bones, then we could appreciate this Wolff's law even more better. So as of today's introductory class, we dealt with the basics or the introductory portion of the bone or the skeletal system. We saw the anatomy and physiology of the bone. Starting with, we saw the basic classification of our skeletal system, the appendicular and the axial. We found the 5 different classification based on the structure and shape. Then we found the macroscopic, then we saw the macroscopic structure of the bone, where we saw the outer bone, the inner bone, the dens and the trabecular bone. And then we also dealt with the medulla. Coming to the microscopic portion, we saw the basic classification of the woven bone and the lamellar bone. The lamellar bone is again divided into cortical bone and the cancellous bone. We saw the cortico-cancellous junction, which is one of the clinically important structure where the tendency for the fracture to occur is more at the cortico-cancellous junction. Then we found why it is called as woven bone, why it is called as a lamellar bone. After that, we saw how the Workman canal or the osteon, which is a structural unit of a lamellar bone, is seen. That we saw the structure of that. Next, we saw the composition of the bone structure. That is, we have the bone cells and the extracellular matrix. In the extracellular matrix, we have again 2 types, the organic matrix and the inorganic matrix. Organic matrix is made of collagen. Inorganic matrix is made of salts, which is mostly the calcium and the phosphorus salts. After that, we saw the different types of bone cells, which are main for 2 important. Also, we saw the 4-time classification of the bone cells with osteoblast, osteoclast, osteocytes, and osteoprogenitome cells. After bone cells, we saw in detail how the osteoblasts are seen, how the osteocytes are placed. We saw the 2-layered structure of periosteum. After 2-layered structure of periosteum, we saw how blood vessels enters. Then we saw a detailed description on a typical blood supply to any long bone. So any long bone has mainly 4 nutrient supply to it, or the arterial supply to it, with the nutrient artery, the metaphyseal artery. Then we have the epiphyseal artery and the periosteal artery. We saw the blood supply to it. Then we saw about the in the macroscopic classification, we saw the different zones of each bone, the epiphysis, the metaphysis, and the diaphysis. The importance of epiphyseal plate was known in today's class. And the last thing what we concentrated was on the bone remodeling. That is, there is continuous bone remodeling that happens throughout the life, and we saw something which is called as Wolff's law of remodeling, which we can it can appreciate in further classes as and when we deal with the further fracture related topics in detail. So in the next classes we will be dealing with fractures. We will start dealing with fractures of each and every bone. We'll take up each and every bone. Before that, we'll start to see the basic classification of fractures, and as and when we progress, we will also then understand how better we can understand the Bhagna and the aspects dealt in Bhagna told by Acharya Sushruta in our classics. Further on, we'll also deal with the dislocation or the Sandhi Moksha, and each one of these and each classification as given by Acharya Sushruta, we'll be seeing how well we can understand and how reliable it was in those times, and how beautifully the fracture was explained by Acharya Sushruta. So with this, I would like to end the current session with again a small prayer. Om Namami Dhanvantarim Adidevam Surasurai Vandita Pada Padmam Loke Jararubhayam Mrityunasham Dataramishan Vividaushadhina. Om Shanti Shanti Shanti. Thank you.